I'm going to talk today on Scanning Applications 2.0. The focus of the talk is on a Web 2.0 applications. Brief introduction, I'm a founder and director of Blue Infi Solutions. We are based in India. Past experience, I work with NetSquare, Chase, IBM, and Foundstone. My primary interest is web security research. I published several advisories, tools, papers and such. I authored following books. Some of the stuff which I'm going to cover is from my recent book, Web 2.0 Security, Defending Ajax, RIA, and SOA. Today's agenda is we'll start with the Web 2.0 state, trends, challenges, and architecture. Then we'll walk through Web 2.0, fingerprinting, discovery, and crawling techniques. The focus over here would be on the methodology part for a Web 2.0 scanning. Then we'll go for Web 2.0 scan. We'll see some of the attacks and tools. We'll see some of the Web 2.0 components like RSS, mashup, blogs, etc. And what kind of vulnerabilities one can identify in these components. Then we'll look at SOA, that's the service-oriented architecture or web services. And finally, we'll see some of the code reviews and web application firewalls to protect Web 2.0 applications. Starting with Web 2.0 architecture challenges, pretty much a lot of web applications are moving towards Web 2.0. If you look at Gmail, Google, Dig, etc. Essentially, the evolution started with social networking sites, and now it is picked up as Enterprise 2.0, where it is penetrating deeper into corporates and organizations. Web 2.0 state, 80% of companies are investing in web services as a part of Web 2.0 initiative. This is a recently McKinsey 2007 global survey. By the end of 2007, 30% of large companies have some kind of a Web 2.0 based initiative. This is a Gartner's finding. And 2008 web services or service-oriented architecture, SOA, would surge. So essentially, web services is essentially a back-end piece for Web 2.0 applications. And if you look at the front-end part, it is a Ajax, RIA, and Flash-based applications. If you look at the Web 2.0, like a Web 2.0 is like application of applications. We have like a network of networks. Web 2.0 is like more application to applications. So over here you have a browser where Ajax and RIA components are sitting on top of your HTML, JS, and DOM. And it is connected to internet, and then you have application server where a web services component is hooked. That web service is essentially talking with various different applications like your banking application, trading application, Gmail, weather application, blogs, etc. And then all these applications are integrated into one application. So several different start pages in Web 2.0 coming, several different enterprise pages which are coming into web application space, which is essentially communicating with a lot of different structures and a lot of different applications. Looking at the Web 2.0 application layers, what you have on a browser, you have Ajax, Flash, RIA technology, you have HTML, CSS, JavaScript. You have widgets and gadgets running on your browser. That's the common application components coming into play. And then you have a DOM context to maintain for your application. If you move down to structures, you have XML and JSON structures. So if you look at the older application where we used to have a query string and a post buffer, now we are throwing back and forth between a client and a server, various different structures like XML, JSON, etc. Various different protocols are coming into picture like JSON RPC, REST, XML RPC, and SOAP. These are the new protocol layer, which is talking with the backend server-side components like a services or SaaS or open APIs and such. And everything, all these structures, everything passed over HTTP or HTTPS. So essentially, this is a higher level view of application layer, which can be dissected into 4 sections. Web 2.0 security state, complex architecture and confusion with the technology. We are seeing on the basis of this, a lot of different vulnerabilities can be discovered, or a lot of different vulnerabilities we are identifying in the application. We have already seen Web 2.0 worms, which is leveraging Ajax-based JavaScripts and such like SAMI, Yammer, Space Flash, etc. Ajax and JavaScript, the focus going on to a client-side attacks like a cross-site scripting or cross-site request forgery. Web services attacks and exploitations, which are more on the server side we are seeing. Flash clients running with a risk of decompilation and such. So this is overall Web 2.0's security state. Some of the real life cases, Gmail CSRF exploit, which was adding filter through CSRF. We have a Orkut XSS worm, which is loading JS file through Flash from Scrapebook. Then we have a making money with a MySpace bulletin where attacking blogs and boards. We have XSS through RSS feed, which is another interesting part. We have a MySpace hacking spread through Flash components and such. We have HTTP response splitting on one of the Google's bloggers, HRS vulnerabilities. So these are some real cases vulnerability which are cropping up where Web 2.0 applications are running their architectures, Z.10 and such. Moving next to Web 2.0 application case. Recently I finished one of the application assessment, which was completely Web 2.0 application. So if you scan Web 2.0 application, you don't find any href, you don't find any URL. So all crawlers or your some of the products or such will just hit a slash page and ends there, because once you hit the slash page, a large JavaScript comes to a browser, it will repaint the DOM, and everything starts from there. So some of the vulnerability we were able to identify is cross-site scripting in AJAX routine. So using eval and document.write, these are some of the calls which we are going to look at, through which we are identify next generation or a DOM-based XSS on it. We have seen a blog is in a fashion. So these applications, what they have done is they took a third-party blog and integrated into their application, and that blog is essentially running with lots of XSS on that. CSRF was possible through JSON stream. We have seen in the morning, we have a CSRF with a typical get and post. Now we can see these new kind of a CSRF. This CSRF is with a JSON stream or CSRF with an XML stream and such. A lot of information disclosure we were identify with a JSON fuzzing. So what we did is JSON structure was hitting to a server, and you can fuzz the JSON structure and see what the behavior of the application, and you can identify different SQL injection points into that. Another interesting finding was SQL injection over XML pipe. So I was able to do SQL injection over XML, which is hitting to a server. And a lot of different logical bugs on a client side were found because a lot of server side code has been shifted to a client side for AJAX routine and such. So what are the major changes and challenges which we are seeing? On application infrastructure, there are 4 dimensions. If you compare with a Web 1.0 with a Web 2.0, what we have is a protocol. Web 1.0 used to have HTTP or HTTPS. So with a 2.0, we have a SOAP, XML, RPC, REST, everything over HTTP and HTTPS. If you look at the information structure, we used to have a get with ampersand going, or a post with the ampersand going back and forth. And HTML is coming from a server to client. Now we have XML, JSON, JS object, JS array, various different streams which are hitting to a server, and server is sending the same string back to the client. If you look at the communication method, we used to have a synchronous communication method where refresh and reload happens. Now we have asynchronous and cross-proxy, cross-domain calls. So essentially, you don't have to wait for the response. You have a little 3 or 4 widgets sitting in your browser, and one of the widgets is doing something, another widget is doing something and such. So essentially, all these calls are becoming asynchronous calls. On information sharing, we used to have a single place of information. Now we have multiple sources of information for a mashup application and such. If you look at the security threats, we used to have in a 1.0 application, we used to have structured entry points to the application. Now on Web 2.0, you have scattered entry points because at the back end, web services is running with a multiple entry points. So you don't have to traverse your application in a one fashion. You can pretty much traverse your application in multiple fashions. Dependency, we used to have a limited dependency with 1.0. With a 2.0, we have multiple technologies to deal with, information sources and protocols. On a vulnerability front, with 1.0, the focus was more on a server-side scripting and a typical XSS, persistent, non-persistent one. Now we have a web services payload to handle. We have a client-side, cross-site scripting and a CSRF with a DOM and a different structures. Exploitation was a server-side exploitation. Now it's pretty much on both the side of exploitation. We are seeing a lot of different tools and toolkits are coming like a Beef and such, which will empower you to do a client-side exploitation as well. On a methodology part, if you used to do a footprinting, we used to do footprinting with just the host. Now you can do, with a 2.0, you can leverage the search engines information for footprinting. On a discovery part, the discovery was simple. For a 2.0, discovery is very difficult. How you crawl the application, how you can discover different calls and such, it's pretty complex. Enumeration was pretty simple with a 1.0 because you can traverse to the application, identify hrefs or form action tags, and from that you can build up the entire map for your application. With 2.0 you can't do that. Scanning was pretty much structured and simple. Now you have difficult with extensive AJAX. And AJAX has their own DOM context, so you have to maintain DOM context to scan the application. Automated attacks used to easy for easy after discovery. Once you discover the URL, once you discover a query string and a post parameters, the attack was pretty simple because you have to change the parameters and send it across. Now it's pretty difficult because you have AJAX, which is making a JSON call to the server or such. So now you have to first JSON stream. There is no %, or there is no typical query string or post over there. Reverse engineering on the server side. Now you have reverse engineering to do on a client side as well with the AJAX routine. If you're running with a Flash, you can download the Flash, decompile the Flash, and analyze it. Code reviews focus on server side for 1.0. Now you have to do a client side analysis as well. Now on a countermeasure front, ownership of the information, 1.0 was simple. Now it's multiple. So if you are running with a mashup application, you are pretty much accessing different information from various different sources. Browser security, simple DOM usage, now a pretty complex DOM usage. Validations on a server side, now you have a client side validation for incoming content. Now you have incoming content which you have to validate before it hits to a DOM. Logic shift only on a server side. Now a lot of logic is shifted to a client side as well. And a source code auditing structured and single place. Now it's a multiple places and scattered for countermeasures. So this is on overall framework of Web 2.0 application, different changes and challenges which we are looking. Now we'll address these changes and challenges with different techniques and tools. First we'll look at Web 2.0 fingerprinting and discovery. Application server fingerprinting, Web 2.0 application running with a lot of different application servers like a WebLogic, Tomcat, and such. We used to have a web server fingerprinting where we do web server fingerprinting. Even you don't get the server banner, though you can identify which web server you're running with, like a tool called AppPrint or HTTP print. You can do that. Now we are taking a one step further and try to identify what is a backend web application server running. So over here, I have a tool called AppPrint. So what it is doing is you have to define a target over here and just start this tool. It is running, it has grabbed the banner, and over here, first banner it is showing over here is a web server banner, and after fingerprinting it has deduced the Apache with a confidence of 77%. This is like we have identified a web server. Now we are identifying application server. So different application server fingerprints I have collected, and this technique is essentially I force the extension. So for example, I want to identify J2E platform. So what I do is I go for .jsp extension. So I will look for I will send a request with a .jsp and try to identify what kind of a 404 I'm getting. On the basis of that, I have identified whether it is running with a Resin, Tomcat, WebLogic, WebSphere, Orion, or a Cold Fusion. So this is the way you can identify what kind of a platform your Web 2.0 applications are running with. Going further, you can identify even a containers. Like if it is running with a web services container, then what kind of a web services container it is running with. For example, Access is one of the Tomcat-based web services container and such. So it is all about the application server fingerprinting. We have a web server fingerprinting done. We have application server fingerprinting done. Having these two information is a critical piece of your assessment process or a scanning process. Next, we want to identify whether this application is truly Web 2.0 application, whether it is making AJAX calls or RIA-based calls, which is a very interesting problem to solve. This is a very simple diagram for asynchronous JavaScript and XML. What you have is HTML and CSS and Flash running on the top in your browser. It will make a call to a JavaScript or DOM, and this JavaScript or DOM will make a call to XML HTTP request object, that is XHR object. Essentially, XHR object is the heart of AJAX because that's the object through which you can make a call. You don't have, in your browser, you don't have a socket, but through XHR, you are imagining you have now a socket in your application as well. So JavaScript straight away open a socket and make a call to your backend server. This call will be asynchronous over HTTPS. It will hit the web server, then it will go to the XML middleware or text, and it will access database or resource. So this is a AJAX call. Now we want to fingerprint and we want to identify this call. So for example, here is a AJAX and RIA call. What you have is a get AJAX that will go for a HTTP open. Over here you have XML HTTP request object created. Then it will go for HTTP open, will get the backend resource or a file, and you have a steady state 4. So this is essentially an asynchronous call. It will fetch the information and send it over here. So for example, if we go over here, there is a plugin called Firebug with a Firefox, which will capture the XHR call. So whenever you are running with a Web 2.0 application and you want to capture XHR calls, you can use this tool. Over here, as soon as XHR call will be made, you will see the URL and what is the response and request over here. So over here, we were able to identify these two calls, and this one is a simple XHR call or AJAX call. And over here, what I have is a prototype library. There are various different libraries for AJAX, like GWT, Atlas, then you have a prototype. There are bundle of libraries out there which get integrated into the application. So over here, this guy is using a prototype. So prototype has its own call, which is making this AJAX call. So over here, I am able to identify this is a prototype call. Now I want to fingerprint. I want to, given an application or given an URL, I want to identify which library this application is using. So for example, whether it is running with Atlas or it is running with a GWT or such, this helps in identifying if a publicly known vulnerabilities exist in a library or such. So what I've done is I've collected certain signatures, and I do a fingerprinting, framework fingerprinting. You can download some of these tools from all these tools from my site. Over here, what I have is a Ruby script which is called ajaxfinger.rb, and I am passing in a bat file certain URLs like a 192.168.1.3 or Dojo Toolkit or apple.com or such. And now I start fingerprinting. So it has done a first fingerprinting, which is on 1.3. It is suggesting over here, these are the list of frameworks like Prototype, Scriptoculus, Dojo, DWR, Moo.fx. All these are the are various different AJAX libraries. So over here, I am able to identify that this particular URL is using the prototype.js. If you go for a Dojo toolkit, it has identified is running with a dojo.js and a jQuery.js, so jQuery framework it is using. And next, on Apple, it is using, say, prototype.js or a scriptoculus.js. So this is the way you can identify. Number one, you can identify this particular application is a Web 2.0 application. Second, it is what kind of a framework it is using and such. So with this, we pretty much capture information about web server, application server, and now we have information on a client side or a client-server combination side of AJAX toolkits. Next, we do a fingerprinting for RIA components running with Flash, because if application is running with a Flash, we want to fingerprint that as well. And for a Flash, there are different frameworks out there as well. For example, Laszlo is one of the framework for Web 2.0 application, which is Java-based Java Flash combination of a Web 2.0 application. So we want to identify that as well. So over here, there is a fingerprinting script which is called flash.rb, fingerflash.rb over here. So I'm scanning, doing a flashfinger.rb on 1.3 search find.html. It has identified these parameters, finder.swf and finder.swf files. Now I'm doing with a search.html page, that's the next URL. And it has identified parameter like a search.lzx files or search.lzx files. These LZX files is essentially files for Laszlo. So what you have to do is you have to create an XML file. You don't have to write any Flash scripts in it. You just create an XML file and push to a Laszlo. When client make a call through a browser, it will dynamically create a flash file and throw it to the client, to the browser. So this is a kind of a framework which is called Laszlo framework, which is worked with RIA. You can download flash file, you can download LZX file and reverse engineer it as well. So this is a fingerprinting for different frameworks which we covered. You can identify this by manually looking at where the parameters are sitting and such. Another framework is Atlas framework. That's a popular framework with a Microsoft technology where you can identify backend references. For example, over here you can see there is a backend reference for trade.asmx/js. So this is a Atlas sitting in your browser on the front end, making a backend call to trade.asmx. ASMX is essentially a web services file. So if we go back over here, next is discovery. Once we have identified fingerprinted different technologies, now we want to discover the calls, actual calls, which is browser making calls to a server or server sending information back to a browser. These calls are essentially having different significantly important structures like a JSON, JS array, JS object or such. And these calls are pretty important while you are doing the scanning or assessment for application. Here are the various different calls which we are seeing. For example, on top we have a JSON. This is a JSON stream, like entire JSON object, JavaScript object notation. Over here I have XML stream coming to me. Over here the entire JS script is coming to me. So server will send me a JS script. I will take the JS script in a browser as a programmer and execute it. Here is an entire JS array coming to me, and here is a JS object. So all these are different streams are for serialization. So this will give a serialization options for a discovery of the application. Next is Web 2.0 crawling. Over here, for example, if you want to do a discovery with Atlas framework, so over here there is an application, say login/trade.aspx page, where I'm entering username and password information and doing a login. And now I just scan Atlas with RB file, giving a trade.aspx page. I will do scanning, and it will identify the backend entry point, which is a trade.asmx/js entry point over here. And if you actually want to do the same thing with a manually, what you can do is you can start a Firebug and enter a username password over here, and you can see the entire structure going back and forth. So post request is sent user Shreeraj, and response is user is authenticated. So this is the way you can identify the structure, as well as you can discover the framework which is used on the top. Similarly, there are various different structures which we already seen, JSON, XML, AJAX. So you can start a Firebug and you can discover these structures. These are different structures you can identify over here. Here's the XML structure we are seeing. Here's a script and such, which we already covered. So once a discovery is done, you can pretty much identify this structure. You can fuzz this structure like we used to do. Whenever we see a query string, we try to manipulate the query string and try to see how application is behaving. You can do all these things with now a JSON structure or XML structure and such. Next is Web 2.0 crawling. Crawling is a major challenge for Web 2.0 application. The entire page is dynamically created. You don't have a static HTML page coming from which you can identify hrefs. So DOM events are managing the entire application framework. So all DOM events are managing your application, and you can browse the application with a DOM context. So you pretty much can't do a protocol level crawling, which we used to do. We used to do a protocol level crawling where we grab the first HTML page, dissect the HTML page, grab all hrefs, and keep on crawling the entire application. With this, you can't do this. So for example, you have a sample page over here. When you hit the slash page, you get these kind of a script. You have like 7 line of page where different scripts are mentioned. There is no href in this particular page. But as soon as this script get loaded in a browser, you can see the backend page, login, news, your area, profile, etc. So this is a dynamically DOM manipulated. So over here you can see there is a load HTML function which is making call to load HTML. It will grab the information which is coming through a AJAX call, over here the 4 or 5 hrefs, and grab that href and post into your browser context. Over here it will post into a main. So you have a div id equal to main where this content is going to be posted. So essentially this entire application is just a one-page application. There is like nothing else. It's like a one-page application where several JavaScript coming back and forth. That's it. So over here, if we go for a demo, dynamic AJAX driven crawl. Over here, for example, this is the first AJAX call. As soon as I loaded this crawl application, it has made the backend call for main.html and loaded these URLs. Next, I click on, say, I look at the source code. The source code is nothing but the few scripts. And now next I go for, I click any other click. I go ahead and say news. I click that. It'll make another call and go for RSS feed widget, load into my DOM. We are still on a demo/crawl. There is no, we are not jumping from one resource to another resource. There is just the one resource which is managing everything. So pretty much you can't crawl these applications. There is no crawler which can crawl these applications. So you click on your area, you get another few links and such. All these are dynamically created links using AJAX and DOM. So AJAX will make a backend call, grab the information and repaint the DOM. Once you fire another DOM event, it will go back, fetch the information, repaint the DOM. So the entire thing is completely asynchronous and AJAX driven. Over here, say, for example, I click a profile, I get the complete new JSON structure coming to me, which get painted on my DOM with this. So if you do a crawling with this, for example, see, for example, I use a crawling with, say, Paros. You try to crawl these applications. You have this is a resource which I want to crawl where we have seen several links in a browser. But when you do a protocol level crawling over here, you are trying to spider the application. You pretty much find nothing. There is no link has been identified over here because all links were DOM driven and dynamic. So you don't identify any links. So what you can do is, for example, over here I usually crawl these kind of application using a toolkit called Watir. Watir is essentially a port for it'll like a IE manager. So from a script you can manage the entire IE. So over here this is a very simple script which I have written. Say open a Watir. Watir is essentially a Ruby based kit which you can integrate as a package into your script. Over here I am saying go to this URL ajax.example.com/demo/crawl. Show me links, slip for 1 second, click like we are clicking manually, like we are clicking each link and try to see how it works. So for example, as soon as I start this, what it has done is it went to a crawl site and it has already loaded into IE and shown me these links. Now I go for a next link. So it has clicked news, it has clicked your area and captured few more links like a trade.asp, bank.asp, mail.asp, and now it has clicked finally a profile page. So this is the way you can crawl the application. There is no way you can crawl the application using the protocol level crawling. You have to have a DOM to crawl the application because everything is dynamically generated with a DOM context. Another tool, which there are several other tools out there, but my favorite another tool is something called Chickenfoot, which is a plugin to your Firefox. Over here I have a simple script, which is I'm saying that wherever there is a JavaScript, use a click link. So over here I run the script. It has loaded this page and now it started clicking every link which is a JavaScript driven links. So where I am able to identify all my URLs from this. So this is the way you can, for Web 2.0 application scanning, there is no one tool by which you can scan the application, essentially. It is a completely DOM-based site. So this is the way you can crawl these applications using various different tools and techniques. So this is a relatively new way of crawling the application because you need to have a DOM context and DOM context with running with AJAX and a JavaScript. So we have seen this Ruby-driven Watir. Next, we will look at the Web 2.0 scanning and some of the vulnerabilities. Cross-site scripting, we know these are the traditional cross-site scripting, which is a persistent, known persistent. We have a DOM-driven cross-site scripting, which is relatively new. Eval calls plus DOM is a combination of XSS with a Web 2.0 application. So while doing a lot of Web 2.0 application scanning, we were able to identify these different kind of cross-site scripting vulnerability. So what is different between native XSS and this one? This is essentially for an AJAX call, so AJAX stream, AJAX-driven call, which gets the incoming stream and evaluating incoming stream or executing that particular stream into a DOM context. These XSS would get generated. Inject into current DOM using eval call, may rewrite with inner HTML as well. There is a lot of Web 2.0 application are using .inner HTML, document.inner HTML call to paint a certain part of your browser, not the entire refreshing the entire page. Source of stream can be untrusted. This is a major problem with a Web 2.0 application because your application is essentially grabbing the script from, grabbing the information from some of the bloggers or grabbing the information from some of the RSS feeds which are completely untrusted. And then you are grabbing that stream and executing into a browser context which will generate access. Cross-domain calls are very common. Addressing cross-domain call. Web 2.0 application is essentially want to access various different portals, various different applications from the back end. So how it can access or bypass the same origin policy. So there is no way they can bypass the same origin policy. So various different methodologies or various different techniques were developed by some of the developers, or a pattern has been set over here. One is a proxy to talk cross-domain. So what developer will do is write a simple proxy onto their application and pass a parameter to that proxy, and that proxy will go out, fetch the information and tunnel into the application. So that way they don't have to do a SOP bypass, or they don't have to do actually a cross-domain call. Another interesting way is a callback implementation to fetch. Google, Yahoo, all these application portals have provided a callback mechanism by which you can, in a script, you can suggest what callback you want to get. With a flash via crossdomain.xml. In a crossdomain.xml, you can define if you want to make a cross-domain call with a flash or not. So for example, over here, a cross-domain with a proxy, you can see the AJAX call has been made to localhost demos xdom /proxy.aspx $URL, wherever from where you want to grab the stream. And these are essentially two different domains. So you haven't bypassed the SOP policy, though you were able to fetch that information. Now over here, this information has been, a JSON structure has been passed to you, and then you are making the eval call into your browser. So this is one way of bypassing the cross-domain call. Second way is, for example, over here in SRC, what they've done is, like in SRC, you are identifying block.example.org/getprofile.html. Then you are defining a callback. A callback equal to profile callback. And these profile callback is essentially a function in your script, function profile callback into results. So as soon as the script call is essentially a script is not binded by SOP, or it can make a cross-domain call. So script will make a cross-domain call, and when it make a cross-domain call, the entire result once come, it will get executed by this particular function. So this is a very bad methodology which we are saying, because your browser application you are making in the mercy of this blog.example.org. Essentially, you don't know what content is going to come from that, but that essentially you are trusting the content which is coming from this example.org. Portals like Yahoo and Google's are supporting this nowadays because it is a very quick bypass for cross-domain. So these applications are supporting this, and a lot of security at stake for this callback mechanism. Now imagine the same scenario for cross-site scripting. What you have over here is a blogging application which is generating a JSON feed. That JSON feed essentially captured by one of the web client. So for example, an attacker would post a malicious code on a blog that will get converted into JSON feed. And when a web client make a call to a web server will go out, use a proxy application, will fetch this JSON feed. That JSON feed will come as a JSON stream. As soon as it will do a eval, the JavaScript get executed on the box. It will compromise the box, or it will cause a cross-site scripting, and the entire session will be hijacked from 8008 port from attacker. So this is the way entire new scenario we are seeing with the 2.0 application. So for example, over here, if we go, say we have this guy over here, XSS with the JSON stream. So over here we are just clicking this show profile, which is on ajax.example.com. And as soon as you click, it's a cross-site scripting. If you look at the backend stream, which is actually coming through a third-party proxy or such, which is where last name is injected as a XSS script. So for example, if you look at the source code of the script over here, here is a eval call which is injecting the stream which is coming from third party and then making a document.write calls. So this is quite possible with JS object or XML or a JSON stream or such. So all the structures which we have defined, 4 or 5 new ways of communicating between for a web application, each one of them can be vulnerable to a cross-site scripting. It all depends from which trusted source this entire stream is coming to the application. Similarly, XSS with RIA is possible. For example, you download, if your application 2.0 application is running with a Flash, download and decompile. Look for example, a get URL call or such. There are a nice tool called SWF intruder, through which you can identify if there are problems with the get URL calls or not. There are decompilers available for Flash, that is called Flasm and Flare, which you can download from this URL. So you can download that entire SWF file and decompile it and see in a clear text. Now, interesting way is like scanning for XSS. We have seen the XHR call, which will evaling or doing a document.write. There is no one click by which you can say that this particular call is vulnerable or not. So it is like more like a manual effort. So what I'm doing is I have written a little script for applications. So scan Ajax component, retrieve JS files, download all the JavaScript file which the particular page is using. From that, you identify XHR call. Once you identify XHR call, look for eval and document.write. So for example, over here, scanning for XSS web2.0 application, we have seen this is one of the vulnerable application or vulnerable page which we have seen for a 2.0 through a JSON, which we already seen over here. Now we run this particular script called scan Ajax, which is a part of a scan web 2.0 toolkit. Over here, what I've done is I have scanned the entire page. So in a first shot, what I've done is I've scanned for a script. So I've identified that there is a script called leap.js. So I've downloaded that, I have parsed the entire JavaScript and identified there is a function called getJSONProfile at line number 1. And then at the line number 4 and 5, there is a XML HTTP request call. So now I know that this particular function is using some kind of a XHR or some kind of a Ajax call. And then on line number 17, I will identify eval, and then 8, 19, 20, and 21, I will be able to identify document.write. So now analyzing this, you can identify whether the application is vulnerable or not. There is no like one click you can identify it is vulnerable to cross-site scripting or not. This is the way I was able to identify a lot of different cross-site scripting bugs in one or two web2.0 application which I have reviewed. Moving next to Ajax serialization issues, we have a XSS with a, see here, document.write and these.subject. Now, this is entire information is passed as an object to the browser, and as you can see, there is a from, to, subject, and body, and then there is a method for showing the subject document.write these.subject. Now, as soon as someone can inject as a part of a subject, if someone injects script, that script is going to get executed on the browser, so it is going to cause a cross-site scripting. Similarly, for a JSON issues, you can inject JSON parameters, you can inject script parameters into JSON or JS array or such. Beef and all different toolkits are available which you can integrate for exploitation of this cross-site scripting. You can hijack, you can do a session hijacking, you can do keyloggers, etc. Using with the web2.0 applications. Countermeasures for it, client-side code audit is required. You have to identify the XHR call and DOM utilization, how DOM is utilized with this XHR call. Content from untrusted information sources should be filtered at a proxy level. So if you are using a proxy to grab different information from the web, before sending it that particular stream to a browser, you have to filter that. So we usually doing a input filtering. Now we have to do output filtering as well, because that that stream may be coming as RSS, or that stream may be coming as a JSON stream, or that stream may be a JS object or JS array. You have to identify that that particular stream is not manipulated, or that stream has no malicious script injected or characters injected. So this is a different approach we have to identify for countermeasure as well. Cross-domain callbacks, if you're making the cross-domain callbacks using the script which we have seen, it should be very careful about that. And if you are making to a completely untrusted source, then pretty much you are putting your security or your end client security to the mercy of them. Browser-side content validation before consuming into a DOM. So these are some of the countermeasures. Above the countermeasures which you are taking for a native XSS, these are some of the added countermeasure you need to put for essentially for this 2.0 applications. Moving to cross-site request forgery, we have a generic cross-site request forgery which was covered in the morning. Generic CSRF is with a get and post, forcefully sending request to a target application and doing a cookie replay, leveraging several tags like IMG, script, iframe, and essentially you can leverage this tag because they are not following the SOP, they are not abide by SOP. So what is different with a CSRF with a Web 2.0 application? Is it possible to do CSRF to XML stream? Is it possible to do CSRF with a JSON stream or such? So essentially browser is making an XML call to the backend application, or browser is making a JSON stream call to the backend. Can you manipulate that? Because essentially the traditional, for example, a Netflix application or such, where the cross-site request forgery was with a simple get, where you have ampersand question mark value equal to V1 or V2. Over here, what we are seeing is completely different structure going back and forth. So for example, here is a trading application where a login has been done, so authentication cookie will come back. Next, that particular client is making a buy request through XML. So it is saying that buy 20 shares of Google or buy 20 shares of MSFT. All these will go into XML structure. It is not going as a question mark buy equal to Google ampersand quantity equal to 20. So once that is done, now imagine the one-way CSRF scenario. This is essentially a one-way CSRF. We will see a two-way CSRF as well. On a one-way CSRF, now that particular person is going to attacker site. That attacker site will force a loading CSRF page to this application user, which is already authenticated to a login application, and that will force the buy request, the XML request to the trading application, and order will be placed. So for example, over here I have a demo, cross-site request forgery. Here is a simple trading application which is running with the Atlas framework with a 2.0 application. Over here you can see it is making a trade.asmx call. So backend, there is a application running with a trade.asmx page, and you are making a request for 25 buy, and over here this is a response which you are getting, but we are interested more on a request. When someone click this buy request, what I've done is that entire XML stream which is generated, and that XML stream has been posted over AJAX call to the target. Over target is over here is a login/trade.rem. This is essentially one of the XML RPC toolkit which has been integrated. So 25 share order for MSFT has been placed over here. And now if you go to over here, this is order is placed. And now you go to the status.html, 25 MSFT order is placed. Now you go for this action. What we are doing over here is we are just going to mytrade2.com. The previous one was completely a trade.com. So this is a completely different, altogether a different domain. And we are onto a welcome.html page. We are just clicking this link. As soon as we click this link, what have happened over here is there is a little iframe over here, and mytrade.com login.trade.rem and new buy request has been posted without the consent of these user because he's already authenticated. So browser has generated an XML stream. Now this is not a typical post or typical get stream. Browser has generated the XML stream, and that XML stream is posted to a mytrade.com domain. And this XML version has been posted, and over here you can see the entire request. Google and 20 stocks are posted to the target application over here. And now if we go to, I think, looking at the source code over here, you can see over here there is an iframe, and iframe as a putby.html is posted, and we'll see the source code of a putby.html as well. So over here, this is a source code. Okay, let me show you the source code. So over here in a source code there is a form, and a form as a action to mytrade.com login.trade, and this action is essentially going through a form, so it won't have to abide into a cross-domain call or SOP policy, so it can make a call to any cross-domain platform. So it has generated this call, and now the stream has been generated through over here a name. I have an input as a hidden, and name with a version less than $XML version as a part of my name, and then rest of the value has been injected into a value stream. And when the actual post will be generated, the equal to sign will be posted by a browser. So a browser will take a name and a value and post a equal to in between and send the stream to the target. So this is the way I was able to generate an XML stream from a browser without XForms. Now in the next generation browser will have XForms as well. So you can use XForm to generate these XML streams. So this is the way the entire XML stream has been generated over here. And a one-way CSRF has been executed over here. So if we go back to a slide, so over here, this is the way the one-way CSRF would work. As you can see, there is a form. Form would have our target action, and then post. Post would have a hidden as an input tag, and then name equal to XML less than $XML version, and value equal to 1.0, the entire rest of the envelope of XML, which is injected as a value, and then document.by.submit, which is generated by JavaScript. So this is the way one can generate the one-way XML request. Similarly, you can generate a JSON request as well. The only thing you have to identify is where you put the equal to sign. So you have to put equal to sign where there is something like a comment or such, which is a immaterial parameter where you can inject the equal to sign. So this is the one-way CSRF. This is forcing XML, splitting XML stream in the form, possible through XForm as well. Similar technique is applicable to JSON as well. Next is a two-way CSRF. When we are talking about the one-way CSRF, what we have done is we were able to generate a request. The XML request was generated, but for example, we want to generate XML requests, and whatever information is sent back to us, we want to read that as well. So it will be actually form a two-way CSRF call. So two-way CSRF is reading the data coming from a target, may getting hold on to important information like a profile, statements, numbers, etc. Is it possible with a JSON or XML? So for example, over here, when you go to attacker site, attacker will post order. At the same time, it will grab the critical information and send back to the attacker site. So how that can be possible? So over here, for example, we have a source, http bank.example.org profile.aspx. Now this profile is essentially sending JS array to us. So this is a Web2.org application, which is when you click on a profile.aspx, it will not send you HTML page. It will send you your profile into a JS array like this, or it may be a JS object or etc. So what you can do is in a Firefox, what you can do is you can overload the array constructor. So in your page, you write a function array, and then write the entire thing, read the entire array and send wherever you want to send. So this will be a two-way CSRF where you are making the CSRF call, and as soon as you get the JS array stream, you are processing it and fetching the information back. So over here, this is a function. I have overloaded the array function over here, and script with src bank.example.org profile.aspx. So if your Web2.org application is vulnerable, the Web2.org application is not making these calls in the right fashion, then these kind of a bug can be created. So if we go for the demo over here, for example, here is a profile.aspx which is coming from mytrade.com. So now what I'm doing over here is, for example, you are going to a page over here. You go to mytrade.com, mytrade2.com, login getprofile.html, and as soon as you go over there, you can see your account information, John Smith, johnexample.com. These information has been stolen and sent to a collect.aspx equal question mark data to mytrade2.com. This information is essentially coming from mytrade.com. So this is the way information can be now. You used to have a one-way CSRF. Now we have a two-way CSRF as well. Over here, this is a function. This is one of the bug which was discovered by Jeremiah Grossman with a Google account, Gmail context, where he was able to steal using this technique. Gmail was sending contacts information in a JS array, or it was used to be a JSON object, which was, you can overload this object using simple object. For example, you know that there is a JavaScript object which you don't know. What you can do is, instead of function array, you can say a function object. So it will automatically understand the entire object which is coming and execute. So this is the way you can generate a CSRF and completely cause a two-way attack. Next is countermeasures for it. Server-side checks, check client content type. Essentially, when a browser generate a native call through a form or such, it will usually text/html. When XHR generates the same call, it will be XML/application. So if your application side, before serving the stream, if you're looking for the actual content type call, you can identify whether this is generated by form or it is actually generated by XHR. So this is the way you can do a filtering. And a client-side check is a stream can be started and terminated by, say, slash, less than slash, or any character which you know that your stream is going to have these character at the front and the back before the JS object or JS array coming. So what your application will do is, your application will take the stream, chop off this character, and then process the JS array or JS object. So if someone is trying to do array overloading, it won't happen, because for array overloading, you have to have the actual true JS array stream. In this case, it won't be that. So there is a good paper written by, I think, Brian Chess from 45. They have come up with this concept they define as a JavaScript hijacking. And they have some of the countermeasures which are mentioned in that paper. This is one of the countermeasures they have mentioned. So client can remove them before injecting to the DOM. Moving next to a Web 2.0 component security over here. There are various other components for Web 2.0 application, like, say, RSS feeds, mashup, widgets, blog, Flash-based components, and such. For example, RSS feed coming into application from various untrusted sources. Feed readers are part of Web 2.0 application. If you go out and search for a RSS reader vulnerabilities, you will find it plenty. Vulnerable to cross-site scripting, malicious code can be executed on a browser. Several vulnerabilities are already reported. So for example, over here I have a small widget, which is, say, RSS feed widget, where I can select a source of my my news item. And as soon as I click that particular source, the entire RSS feed from untrusted source would come into me and get repainted as these kind of links. And as soon as I click one of the links, it will cause a cross-site scripting, because this RSS feed is manipulated. So over here, for example, here is accesses with a RSS feed. Here is my RSS feed, which is like one of the examples in several places. So it's quite vulnerable. So over here, I am going for a proxy.aspx and grabbing information for, say, rssnews.example.org, from which I am grabbing their RSS feed. So I go over here and I click that. So over here you can see the entire RSS has been coming, and here is the complete RSS piece. Now over here there is a link. Now these link where someone has injected JavaScript :alert XSS. So now as soon as someone will click this guy, interesting news item, the cross-site scripting will get executed. So this is the way cross-site scripting with RSS feed is possible. Next is mashup application API exposure for mashup suppliers. application cross-domain access by callback may cause a security breach. Very interesting. For example, I have seen several applications where what they do is like when you go to the application, there are different widgets sitting. One of the widget is say Gmail widget. So what you can do is you can apply your username and password over there, and you can read your email over there. Now I was looking at these applications. If you look at the authentication, they are not over SSL. So essentially, when you are sending this information to these widgets, these are essentially going in a clear text. Next, you don't know where they are storing this information, which you have already passed, or you don't know how they are sending this information to an end client or a Gmail, whether it is going over SSL or not. So there are several issues with a mashup. Mashup application is essentially like a man-in-the-middle attack. So for example, you are hitting a mashup application which is getting a maps from a Google, and you are assuming that these Google maps are correct. But what if they are manipulating the Google maps in between? So you are assuming that these maps are coming from a Google application, but they are not actually coming from a Google application, or they are coming from a Google application but get manipulated. So this way mashup applications are pretty much vulnerable to several different content manipulation or untrusted manipulation or such. Widgets and gadgets, I have reviewed some of the applications which are running with the widgets and gadgets. There are very interesting findings out there. Actually, these all widgets are running with the same DOM context. So you have like 5 different widgets you have loaded. What you can do is you can load a 6th widget, which is by which you can manipulate different widgets DOM, because it is using the same DOM context. So once you know the entire DOM context, what you can do is like you can inject one of the widgets which will keep a watch on your Gmail widget, and as soon as someone enters a username and password, you can steal that password from the DOM context and send wherever you want to send. So essentially, if a right framework for widgets and gadgets were implemented, for example, Google has implemented complete widgets and gadgets framework using different iframes. So what you have is like when you load different widgets or a gadget into a DOM context, it'll get loaded into different iframes. So their DOM is completely different than your master DOM. So they can't manipulate it. So inter-widget communication won't be possible. So widgets and gadgets, if you are looking at the application which is using widgets and gadgets, a lot of different findings you can do using that. Blogs are common with Web 2.0 application. Many applications are plugged third-party blogs, which I have seen. They want to quickly put up a blogging application, so they go out and grab an application like Pebble or such and implement into their system. The fundamental problem with the blogs are 2 places which I have identified. One is a search. If your blog has a search functionality, you can identify some sort of a cross-site scripting over there. And a second is exception management. So if exception management through which you can identify cross-site scriptings. Moving next to SOA and web services, which is forming the backbone for Web 2.0 application. So if you look at the SOA stack, you have a presentation stack with XML, JSON, JS object and such. You have a security stack, which is a WS security. You have a discovery stack with a UDDI and Disco. You have an access stack with WSDL, SOAP, XML, RPC, REST and such. And then bottom you have a transport stack, which is HTTP, HTTPS. On a browser, web services get consumed directly through using AJAX or RIF or a Flash framework from a browser stack. So this is a kind of a SOA or kind of a web services we are looking at. So scanning SOA in secure web services, you can do a black box testing using footprinting, discovery, enumeration, and vulnerability detection. From white box testing, you can do a code on config scanning. Based on that, you can come up with a secure coding or web services, and you can secure your entire web services. So techniques for footprinting and discovery for web services, there are 2 ways you can identify with these particular. So for example, you want to assess xyz.com. So you want to identify whether xyz.com has 1, 2, 3 or 5 web services running. So what you can do is you can do either a primary discovery, actual crawl application, spider application, and identify these web services. You can do a script analysis, page scrubbing, or traffic analysis through which you can identify this. So primary discovery, crawling application mapping files, look for .asmx, look for .wsdl. These are the file extension for web services. You can do a page scrubbing as well, or look for a traffic for XML, RPC, REST, SOAP, or JSON. So for example, over here, I want to do a page flex. The page flex is one of the application which is completely Web 2.0 application, different widgets sitting over here and such. So what I've done is I can do with automatic fashion as well, but to show the manual way, I have saved this particular page over here. So this page has been saved. with all the scripts and such. It's very important you download the JavaScript as well, because now JavaScript will having all these resources which you are looking for. So essentially what I've done is I downloaded this entire page, and these entire pages with a lot of JavaScript and such. So over here you can see these are the JavaScripts, and then I'm making a egrep for dot star. It's like a regex pattern. I'm looking for ASMX and I identify that this particular page has this many web services. Now imagine each web services would have number of calls, and each call would have number of inputs and output stream going. So for example, this is like a one-page application which may have like 1,000 or 2,000 calls, which may be XML, which may be JSON or such. I have seen last start.com, which is the Microsoft page. They are using a one master web services at the back end, and that particular web services are almost 132 calls. So 132 functions were defined in that particular web services. So this is essentially a primary discovery. So you are actually hitting the site and fetching this information. So you can use URL grep. That's another part of a script, scan web script, which have toolkit, which has different scripts. One of the script is URL grep, by which you can identify all JavaScript and then run a regex pattern to identify whether there are any hidden ASMX file or hidden WSDL file or such. So interesting ways you can do this discovery. Next is doing a primary discovery. Next is doing a secondary discovery. Secondary discovery is essentially we are not hitting the site, but what we are doing is we are going out for search engines. We are utilizing search engine APIs and try to identify whether any of the web services are running or not. I have a tool called WS Scanner, which is essentially a .NET based tool for scanning web services, .NET web services. So over here, here is a tool. What you need to do is you have to pass on the Google API key over here. So once you pass that, so for example, I want to identify that how many web services are running on Amazon.com. So I enter Amazon.com over here and I look for domain. So what I'm doing is I'm running a query like file type, looking for a file extension and such, and I identify that Amazon.com is running with the 5 web services. So these are the list of web services. Next, I want to see, say, Microsoft.com. How many web services are running on Microsoft.com? So over here, I have identified 101 web services are running on a Microsoft.com. So this is the way I'm doing a discovery of a web services through secondary source. This is not a primary source. I haven't hit the actual URL or I haven't hit the actual host, but through search engines, I'm grabbing this information. So this is the way you can do a discovery for web services, fetching from search engines. Next is enumerating and profiling web services. You have to profile web services, and web services profiling can be done using a WSDL file. WSDL file looking for methods, collect input and output parameters, look for security implementations, binding points and such. So for example, over here I have a same tool where there is a component called vulnerability scanning. So over here I am enumerating with WSDL. So here is a dummy application where there is an access point. If you click the access point, there is a WSDL file where the implementation of the application is residing. So now you can enter this tool. I'm passing a WSDL to it. I'm calling get over here. And over here you can see the entire profile has been generated. These particular web services has these many 4 methods: intro, get product info, get rebates info, get security token, and each of these methods has following input and output. So essentially now you know that what it is taking as input and output. Once you have these information, it is like a query string or a post buffer, nothing else. So now you can inject any parameters into input and try to see the behavior of the application. So the same old web hacking, but now this web hacking is over XML, SOAP, JSON stream and such. So it is like a web hacking reloaded, or web hacking which is the entire stream is different, but the concepts, all concepts are same. Now you can check for SQL injection, you can check for XPath injection, everything you can check. So now you can go ahead and even invoke it. So for example, what I'm doing over here is I'm starting a listener and I'm invoking get product info method. So when I invoke this get product info method, you can see this is a SOAP envelope which is supposed to hit my server. So this is a web services where there is ID equal to 1 parameter which is going to hit, And once I say send, it will send on the wire and get the first information on the product is Finding Nemo 1499. So this is the way you can invoke this. Now over here I can manipulate these parameters in the XML stream and try to see how application is behaving. So over here, scanning strategies, we can see manual invocation and response analysis, dynamic proxy creation, which we have done. Over here, this tool essentially what it does is it creates a dynamic proxy. So I wrote a code which will take the WSDL file, and from WSDL file it will generate a dynamic proxy. So then I have to talk with the proxy, and proxy will do the rest of the things. You have to do a fuzzing with a web services stream now. You have to fuzz XML, you have to fuzz JSON like we used to fuzz query string and post buffer. Interesting analysis is a response analysis. How you can identify a response, what if web service is running with a problem or not. So look for fault code nodes, which is a very, very juicy part of our web services. Enumerate fault strings. There are many times web services will send a fault strings. Dissect XML message and find these bits and pieces. Even hidden error messages are residing in a JSON stream as well. So for example, injecting fault over here, I'm injecting with a double quote over here, or I'm doing the fault code analysis with a first. So for example, let me show you a quick demo. So over here, I'm doing scanning for vulnerabilities. I'm doing a parameter tampering over here, say. So what I'm doing over here is, instead of ID equal to 1, say I go for a $sign and look for a response. Nothing happened over here now. I injected, say, double quotes over here. Now over here you can see 500 internal server error, and down the line you can see the fault code and a trace. And over here you can identify SQL connection on error and such. So for example, over here you can see this is a right perfect place for SQL injection. With a 2.0, the bugs were fixed, but before 2.0, I reported 2 bugs to Microsoft, and they fixed it. One is with SOAP, you can identify SQL injection point, and second is you can identify XPath injection points. With the same tool, what you can do is you can do auto audit. So I have an audit piece over here where you can define different auto audit pieces. So for example, I want to do a data type check, I want to do SQL injection, I want to do LDAP injection, whatever you want to do, you can put that, and whatever character stream you want to pass. Even you can pass what you are looking for in a response. So what I have over here is a SOAP response analysis where I am looking for 500 and fault code over here. So I have that going, and I do auto audit. So it will do the entire web services for that particular parameter will be audited, and it will show me all different errors reported and such. And next is you have to fuzz web services. So over here there is a tool called WS Fuzzer as a part of this tool. So you define a target host, you define a fuzz load over here. So this is my fuzzing load where I want to say I want to inject these are the pattern which I'm looking for, but this is my fuzz load 1 or equal to 1, and these are my pattern which I'm looking for. So I define these two as an input parameter over here, fuzz load and pattern matching, and wherever I want to fuzz, I do ID fuzz hash over here. So interestingly, over here, this is XML stream which I am fuzzing, but many applications which I used to take a JSON stream. So I write a JSON stream over here, and whichever variable I want to fuzz, I put a fuzz hash over there. And now I will do a fuzzing. So I will start my fuzzer, and it will show me the red with the pattern matching. So over here I found fault code. Some of the bad requests generated, 500 internal server error I have identified over here. Some of the schema errors I have identified and such. So once you start fuzzing, you can identify many different errors. Next is you can do a lot of injections. So web services method are consuming parameters coming from end user. It is possible to inject malicious characters. XPath SQL injection, malicious file execution is possible. Try to inject a file execution parameters like a pipe and a command and such. Insecure direct object references, ///, you can inject that as a part of a SOAP analysis, SOAP message. And information leakage, SOAP-based web services throw fault code. From fault code, you can identify a lot of information. And finally, for failure to restrict URL, what I've seen is some of the web services are running with some of the methods which should not be public, like admin method is already implemented and is a part of a public, or it is forgotten as a public or kept as a public. So what an attacker can access these methods as well. Once he has access to WSDL, it can identify these methods and make a call. If we go back, here is a say SQL injection. Over here, I'm just doing SQL injection over here. 1 or 1 equal to 1, the same old trick which we can play with a SOAP over web services or with a JSON RPC or such. So here I got the entire stream. So we have in XML, part of XML envelope, I am able to identify all the product or the entire table list over here. Similarly, I can do XPath injection or command line injection or such. So pretty much whatever we have seen, all OS top 10 attacks or all WASC attacks, everything you can pretty much do using this method. So finally, looking at the defending web application, we used to defend web application with a code review or a WAF. So for example, when you are doing a code analysis, source code analysis, scanning the code base, identifying linkages, method and signature inputs, looking for various patterns for SQL, LDAP, XPath file, etc. I have written a little utility called app code scan, which you can download. Here is a typical app code scan utility. What it's going to do is, for example, I want to scan a web services. So I want to scan a web services code. I have a WSDVDs for less over here. And here are my rule. And over here, I am putting ASMX. So what I'm doing over here is I am saying that scan for all ASMX pages, which is my web services resources, look at my rule file and scan these particular folder. Now rules file this is my rule file, which is based on different XML, different regex patterns. First, I'm looking for web methods. I'm interested in web methods because these web methods are essentially a web services methods which I can invoke over HTTP or HTTPS. Next, I'm looking for session enabled methods. There are certain methods which are enabled by sessions. So then these are the session enabled methods, and some methods are not session enabled. So with these pattern, I'm looking that. Next, I'm looking for public methods because public methods is able to invoke over HTTP or HTTPS. And next, I'm looking for a dependency, whether it is dependent on system.web services. If that particular file has these dependency in it, then I know that this is actually a web services file. Then I look for file, stream, select, SQL command and such. Now I run my tool. This is a fast way I used to do application code scanning assignments. So over here, I have identified all the calls with a line number which I'm interested. I haven't opened a file yet. I'm just using this tool for that. Over here, I identify these are the public methods, like say get rebates info, get product info, file info is my method. Now what I'm doing is I'm interested how file info has been implemented. So I took a file info and started to using my utility called code walker or stack or trace scan. Now I'll take a file info, pass it to a walker, and then I will get the line number 49 where file info has been used. Next, I take a product file because that is going into this product file variable. So I took that. Next, I take a FS because I want to trace the entire stream. So I got the FS, and now from FS I got the SR over here. So I take the SR variable and try to see how that is implemented. And SR is directly hitting to the file stream over here. So entire file info which is traversing from my public variable and hitting to a file system. So over here, if someone is actually injecting boot.ini, then that boot.ini is actually go over to the target. So this is the way you can do a source code analysis for specific for 2.0 resources. Next is doing a content filtering with HTTP with a 2.0. Regular firewall will not work because regular firewall is usually looking at traffic for a buffer and a query string and such. Where you have to see a SOAP and a JSON based traffic. ISAP level filtering is essential, SOAP and a JSON content filtering through IHTTP module. So I usually write an IHTTP module for .NET There is a utility which I have released, something called Web2 Wall, which you can download from my site, where there is a simple DLL which you can inject into a Web2 application and defend the SOAP filtering. So over here, what I'm doing is I'm just writing a HTTP module which is going into a Web2 application and then look for a Web2 calls. So for example, if we go for this guy over here, we have seen a vulnerability for trade.asmx. Now here is a Web2 wall, and you have IHTTP module with a web shield. This is a tool, or this is a DLL, and in DLL I'm grabbing rules by which I want to scan, or which I want to filter, essentially. So I grab all the rules for XML or a SOAP message, which are part of a webshield.ini. Over here, I look for a post, grab entire post method, and if any regex pattern has been matched, then I throw a security error. So over here, for example, I am sending get quote method. It's the quotation site. So I send it across and I say IBM. So I send IBM as a symbol, and I get 25.32 as a rate. Now next I try to inject double quote. Now this double quote is a part of my XML tag which I'm looking for. So as soon as I send that, I get a security error, because the ISAPI or the HTTP module will hit first before it actually hitting to a source code of my web services. So this is the way I can defend .NET applications. A similar module is available with Apache for a mod security module, which has now XML implementation done. So this is the way you can filter Web 2.0 resources. So conclusion, Web 2.0 bring new challenges like a crawling challenge, discovery challenge and such. Needs to adopt new methodology for scanning, which we have covered in the entire presentation. Attacks and entry points are scattered and multiple, so you have to do a proper analysis for that. AJAX and SOA are key components of a Web 2.0 application scanning. WAF and code review are important aspect for Web 2.0 defense, which need a little tuning compared to a typical Web 1.0 applications. So that's pretty much it from my side. Thank you very much for listening me patiently, and if you have any question, let me know.